Today let's learn something to print called line of symmetry and center of symmetry. Let's start. Look at the heart. Now let's fold his figure in half. You will notice that both the halves match each other exactly. Rule: if you can fold a figure in half so that the two halves exactly match, the figure is said to be symmetrical. The fold line is called line of symmetry or axis of symmetry. Definition of quadrilateral. A quadrilateral is a polygon with 4 sides and 4 vertices. Definition of diagonals. A diagonal is a segment that goes from one corner to another but is not a side. To understand what the symmetry is, let's draw an isosceles triangle. Its triangle has 2 equal sides. Let me give an easy task. You need to think if you can divide this triangle in 2 parts, such that both of parts match exactly when defolded along a line. How which divided this triangle if this condition have to be satisfied? If we draw a line like this condition will be satisfied. Yes, it is the vertical line which divided this triangle in 2 parts, which match exactly folded along the line. If the parts of right is taken over to the left, so the 2 parts are overlap exactly. I draw an isosceles triangle like this and ask you the same question. How we divided this triangle in 2 parts such that both the parts match exactly when they are folded along a line? We draw a line like this. When one of parts flip, it is overlap exactly to the other. Both of line called line of symmetry or axis of symmetry. This line have vertical axis of symmetry and this line horizontal. Look at this rectangle. These 2 parallel sides are equal and these 2 parallel sides are equal and all 4 angles are 90 degrees. It will have a horizontal axis of symmetry like this. When one part of a flip over, it will overlap exactly with the other. We also have vertical symmetry like this. Flip one part of them to the other is exactly equal. So, a rectangle has 2 lines of symmetry, horizontal and vertical axis of symmetry. Wait, is the diagonal is also an axis of symmetry? Let's see the diagonal like this. You can see the fold along the diagonal task not matching parts. You can try to the pages on notebook. Try folded along a diagonal and you will see that the parts do not overlap exactly. Can a figure have more than 2 axes of symmetry? Yes. The square. All the sides are equal and all 4 angles are right angles. It has a horizontal and vertical lines are lines axis of symmetry like the rectangle. But in square also the diagonals are also axis of symmetry. If we folded along these diagonals, the parts match equal. And for the second diagonals, the parts overlap is exactly. So a square has 4 axes of symmetry, horizontal, vertical, and 2 diagonals. Now we are begin by central symmetry. We have 2 copies of 4 different figures. I think about which of these figures will be unchanged if we are rotated 180 degrees. Example, 2 cups of square. We are take one of these copies with rotate 100 degrees around its center. The figure looks exactly the same. Square unchanged by 180 degrees rotation, so it have a center of symmetry. Now the trapezoid. we are rotated 180 degrees, the figure is changed. Now, I have the base is short and the top is long. Before, the base is long and the top is short. So, the trapezoid changed by 180 degrees rotation and no center of symmetry. Look at this parallelogram. Look at its center. The distance between that point and center keep going that same distance again to that point, and vice versa. So the shape unchanged by 180 degrees rotation. Now we rotate it, give the same figure. So have a center of symmetry. About this triangle, this is the center of figure. If you take this point, go to the center of the figure and go to the same distance again. We don't have a place of point. This point go to there and this point go to be there. Now we rotated 180 degrees. The figure is a change, so no center of symmetry. Guides, now it's time for you to practice. First of all, memorize page 226 on book. Then, solve exercise 4, the parts A and B, plus exercise 5, the parts A, B, and C, page 65 on practice book. Then, solve exercise 19 and 21, page 233 on book. I'll give you the pages of rules and of homeworks.